Hi, welcome back. Here's the second part of my presentation. Is a hands-on lab with Azure Machine Learning Studio. So here's a link. You can click on it to open the Azure Machine Learning Studio. Here you need to register a new account and create a workspace. It's free for you. I already registered, so I will not go through it, but you can do it very easily. It's like register for new Facebook account, Instagram. So first thing we need to know what we building. So we will build a predictive model for credit risk, and this is a data set using the German credit data. I provide the link here from UCI. It have 20 variable for 1,000 past application for credit, and the last column is label. So it's a high risk or low risk, and you can open the link here to see how they explain the data. So here's a link. Here is a variable. It's shown here for you. You want to see. Go back to our slide. You can see it also provides the cost function. You see here. It have the not the cost function, the cost magic. So in general, is you predict the customer good when they are bad. It's 5 times more costly if you predict a good customer as a bad one. So we can cover that. So here you see the false dismissal is 5 times more costly than false alarm. So you want to alarm even you like it is better to have the false alarm than the phone dismissal. And to one simple way to include the cost magic in your model is you replicate the high credit risk record 5 times. So if the model predict the high credit risk person as a low credit risk, it should make the mistake 5 times, so it increase the cost of the error. So we can go to the website, web-based experimental here. I already did some, but I will create a new one. So first is a data set. Oh, you need to convert the data set first. So you go to the data folder here, download the German data, save it to some location. I already did that, so I have this thing over here. I have this over here. So you need to, because this one using the blank separated value format, so every column separated by the blank, and you should convert it to the CSV separated by the comma. This is better for the machine learning studio. So to do that, you need to replace. You can replace in Excel. I'm going to replace in powerShell here. Click Shift and right click, and you see the powerShell window here. Open PowerShell, and you go to the slide, copy the code I put here for you, paste it here. You replace every space with a comma. Go back to see the CSV. You can open it to make sure it's a correct value. So here is CSV. You open the Excel, is automatically put it into the column for you, but you open in the notepad. You see it's using comma to separate value for you. So close PowerShell. So we go to the website here. You upload the new dataset from local file, choosing the one that you just created, the CSV file. put a name. So I already have the same dataset, so I just click here because it's a new version. But you create a new one, you can just remove it and type the name here. And this have no header, so you select this. You can put some description here. I'm just leave it as blank. Click OK. See the uploading. So we can go to dataset and verify that is freely uploading. So you say OK. You can see it here, the upload time, to make sure it's the current one. Now we need to go to the experiment and you create a new blank experiment. So you name it credit risk experiment over here. So you can see here is a interface. On the left hand side you have the tool, like the node in the SaaS Enterprise Miner is a similar, but in different way of displaying. And this one is a property, so it changed. This one, this panel in SaaS Enterprise Miner will be on the left hand side, and this one will be on the top here. But don't worry, it's very similar. And here's a mini map. So this is a experiment, is a diagram over here in SaaS Enterprise Miner, and you can zoom over. So we have nothing here, but this is control how to see the diagram. This is similar to SaaS Miner, you already know. So you can writing your summary and description here to make sure you know what you save later. You can even check it later on. I will leave it as a blank to save time. And first thing, you need to put your dataset, and I go to save dataset, my dataset, and I have this dataset I just uploaded a few seconds ago. So this dataset, we can right click here. I mean left click, and you see visualize. You can see it has like static. You click the variable, you have the summary statistic. You have 4 unique value, no missing, is a string, and this is a distribution of 4. So to see what A14 mean, you need to go to the description in UCI. So this is a description. So I will not go through it, but you can see here is because the data have no header, so you don't have the variable names. You only have the column 1, column 2 to the last column, because it's just the name that's Azure Machine Learning Studio generated for it. So I want to put the column name here. I just search from edit metadata. Here you can see this tool I think is better than the SaaS Miner for the searching. So you can just search here what you need and it show up. You don't need to go through everything to find what you want. It's very intuitive. Connect it, and in edit metadata, you need to just drag it into your diagram, and then you click the launch column selector, and you select everything. Click this arrow to put it in the right hand side. Click OK, and then you put the new column name here. You can go to the UCI to select the column name here, but I just provide a list for you here. Just copy it in. Copy and go back to Machine Learning Studio, paste it in, and then let's see. Yeah, you can run it. Run over here. It's a run button. It'll take a few seconds. Oh, It's like longer than I expected. Yeah. Oh, it's I don't know. Yeah, it's finished running. Here you can live from here. Let's see the column have the name you put it in. I think it's okay now. So next thing you need to split data into chaining and testing. So you just split data. Just type it in the search box. It's shown up here for you. So I just drag it in, join here. So you can see here you can have the left output and the right output. You don't have the specific testing and chaining. You can split whatever and you choose as your choice. It's not left is the chaining. You can use left output as the testing. It doesn't matter. So this is the percentage of the left. So it's 50-50. If you put 0.7 here, it's only 70 for the left, 30 for the right. So let's just leave it as a default 50-50 split. And oh, one more thing I forgot, you can put the command by double click and write command. Here we add header variable names, and then you can save the command and later on you can see what you do. What you did here is to know, yeah, because this is hard to follow. We have the big diagram. In the splitting data, we just write split chaining testing set 50-50. Okay, so the next thing we need to put in the cost function, as I said over, I think over here, yeah. You replicate the high credit risk 5 times. Everyone with a high credit risk will be replicated 5 times in our data set, so it's like duplicate 5 times. So you can use the R script. I already put it. So you connect the R script. That's the lab output is we're gonna use the lab output of the training to the first input. This is the first data set of the R script, and we're going to change the code here. I provide the code for you over here, I think. Yeah. So I will explain it very fast. So the first thing you assign the map input port. So this is the first input. This one, port 1 to the dataset called dataset 1. It's like a table. And then you select only value with good credit risk, which means the last column, column 21 equal to 1. You select it in, and then you find the position of every row with high credit risk. The last column equal 2, and then you do the for loop, run 5 times. You append the data from this position in the data set, and you map the output, which is this output. This port is the output. You map it with the output data.set. So that's it. You do the same thing for the testing. So copy this node, paste this here. Same thing. You should keep the same code for you. So next thing, after splitting and a little bit of cleaning, not cleaning, you add a new header and you change you replicate the data to include the cost metric. The next thing you need to do is changing the model. So for this model, you can go to you can find a lot of model here. Where is this? Here machine learning, and you have inner model, a lot of model. I will use two different model here. I use the two class SVM support vector machine and two class position G. Position G. So for the tree, put this thing here. You need to change the model module. Put it here. So this is a xeric model with parameter here. I will not go through the parameter, but it's not the scope of this presentation. This you can connect the model and the data. This one is the data output, which is included 5 times the high credit risk value. And you need to launch the column selector over here. We just put the credit risk at the label. Okay, this is the label for you. And SVM is a little bit more complicated because SVM work better with normalized data, so it's the same range. So I put normalized data node here. Remember, let's use this as a test, chaining, and this is testing. You can write here testing data. Right here, chaining. So later on you can see. So I click here to hide the command. So the normalized data come from the here. Select what you want to normalize. I'm using this function, tinish function, to normalize, and click launch column selector. You wanna include everything numeric, but the last one is the label, so you will not want to include that. You will exclude the credit risk column. Is the last one. I think it's okay for now. Yeah. You need to connect this with the chain model too. Chain. Excuse me. Same setting as this one. This data set output, and this is a model. Sorry, that's too small here. It's just move it. So it's easier to connect things. So here, you have I think you have everything correct now. In the chain model, you need to select the label again. Credit risk. Yes, when it become more clutter, you can use a zoom in and out here. And this is a mini map. You can see it inside here, so it's easier for you to navigate through the diagram. So after the normalized data in the chaining model added in, you want to evaluate these two model. So I'm gonna put the score model inside. Score model over here. This is a chain model. So this one connect here, and this is here is a testing dataset. So it's this one, not this one. Copy, paste it for this model. Oh, I forgot it. You cannot connect it directly because this you need to normalize this again. So you need to copy this and paste the normalized node first. This one will have to go through the normalized before. Let's go to score model. Everything look good now, I guess. Let me check again. Yeah. So after scoring, you have the evaluate model. You can compare two different models, so only two for this tool. And click run. It will take a few minutes, I guess. Oh, yeah, a few minutes. I will speed up this part. Hi, it's finished running. So you can click here, see the output from the evaluate node. This one. So you have the ROC code for the present record and the leave. This is the left input of the evaluate model node, and this is the right input. So you can see in ROC the left one is better. The left one is the boosted to class boosted decision tree. So yeah, you can select what model you want after using this tool, and yeah, it's the machine learning studio also have a very powerful tool for you. As you can see, it's the run history. So every time you run, it saves a snapshot of your experiment. So you can see, if I go back to this one. Oh, is this just, yeah, this is the last one. Let me see when here. Yeah, this one, after I run to edit metadata and I check those add the column name in, it save the snapshot here. So you want to go back to whatever state you already have, and sometimes you change something and you cannot have it back. You can go to run history, and then you can save it as something else, and keep going on your main project. So yeah, that's it. Thank you for watching. Bye bye.